did you choose to eliminate? Y. Okay, we're eliminating y. So I'm going to choose two of the three equations and eliminate y. I'm going to choose 1 and 2 because those are nice ones and they go away easily. Okay, because it's positive 1 and negative 1. So I choose, make sure you write down which equations you choose so you don't forget and remember what you're eliminating. So I have x plus y plus z equals 3. I have 2x minus y plus 2z, equals 6. Add them together to eliminate y. X plus 2x is 3x, y is cancel, plus 3z equals 9. Once you get to that point, stop and go to your next set of equations. So now, which equation do I have to use for sure? I must use equation 3. I have not used it yet. But then you can pick whatever other one you want to use. So it's 3. Now remember, this is where people make mistakes. You must eliminate the same variable in this one that you eliminated in 1 and 2. What did we eliminate 1 and 2?
Y.
We eliminated y. We can't choose something else, even though it would be nice if we could choose 1 and 3 and eliminate z's. If you do that, you're going to get stuck. You have to eliminate the same thing. So I'm looking at equation 3 and thinking, okay, I got to get rid of the y, so I want to use 1 or 2. Well, this one's already a negative, so I'll use 2. Okay? Equation 2's got a negative in it. So I'm going to write those 2 down. 3 is 3x plus 2y minus z equals 13. And number 2 is 2x minus y plus 2z equals. Now, can I just eliminate y's right away? No. I have to distribute what to the second equation? The 2. Because I want to make my y's 2 and negative 2. You'll multiply this by 2. What's that?
So it's going to multiply by 2?
Yep. So that gives me 4x minus 2y plus 4z equals 12. Now, can you add the equations 3 and 2 and get rid of the y's? Yes?
I'm confused. Why are we distributing it?
Because I want to get rid of y's, right? And in equation 3, what is my y value? Positive 2y. So when I add this, what do I have to have this one be to get rid of the y's? It has to be negative 2. This one's positive, this one has to be negative. So what do I need to multiply this entire equation by to get a negative 2 here? By 2. Okay? Good question. All right, so here I go. I have this equation, and I'm going to rewrite the first one down so that I don't make a mistake. If you make a mistake, I am telling you right now, it takes a long time to figure out where you went wrong. So be very careful and write neatly and keep your stuff organized. Okay, 4x plus 3x is 7x. The y's cancel. 2y plus 2y, negative 2y plus 2y. And then I have 4z minus z, 3z, and then 25. 13 plus 12. Now, I have 2 equations left. Both of them do not have a y. I just have x's and z's. If you think back to when we did 2 by 2s, 2 variables with 2 equations, and with elimination, hopefully you remember a little bit of how to do that. So that's what you do next. You use those 2 equations and eliminate either the x's or the z's. In this case, which one's easier to eliminate, the x's or z's? The z's. Yeah, they're both 3. I just have to make one or the other negative. Okay, so choose. Here's what I like to do. I like to box them in so I don't lose them in all my. Okay, and I think to myself, okay, I need to eliminate z. And when I do these, I always put a line through my z so I don't confuse it with a 2. It happens a lot when you do these types of equations. So I'm going to multiply one of these equations by -1 so that when I add them together, it gets rid of the z. I'm going to multiply this one by -1. So I'm going to get -3x minus 3x, or minus 3z, excuse me, equals -9. Then I'm going to use the other equation, 7x plus 3z equals 25.
How do you know you want to get rid of the z's and not like the x?
You can, but do you see how, if I got rid of x's, do you see how one x is 7 and the other x is 3? That means I have to get them both to the least common multiple, which
I
is
see.
21. So I would rather do the x's so I have to, or the z's so I have to multiply by -1 on one equation. Okay? So now we're going to eliminate. So I have 4x, these go away, equals 16. Oh, finally. Can we find x? Yeah. Divide by 4. X equals 4. Now if we know x, what do I do next? You ran out of room? That's why I go like this.
Well, we don't have smart.
I know. You don't have a smart board at your seat. I'm sorry.
We should.
I tried to give you a lot of room in there. I guess I didn't
I have
give
a
you
smart board right here.
enough. Now, what do I do when I have x?
Oh, plug in one of the equations.
Plug it in. Take one of your boxed-in equations. That's why I box them in, so I can find them easily. Take one of your boxed-in equations and plug in x. So I'm going to take 7 times 4 plus 3 times z equals 25. So I have 28 plus 3z. I'm just playing algebra. Subtract 28. 3z equals -3. Z equals -1. I did that pretty fast.
I didn't see a thing, I just did.
I just solved the equation for z. 4 times 7 is 28. Subtract 28 divided by 3. Yeah. Now I have a z and an x. Choose one of your beginning equations. Doesn't matter which one. I like the top one because I don't have to do any multiplying. Okay, so x plus y plus z equals 3.
Oh wait, we plugged the z into the other equation and we didn't get that.
No, not this one, up here, because we have an x and a z.
Find the z. Did you plug it in now?
Yep, I plugged it into one of these two because if I plug it into one of these, I still have 2 variables. I don't want that. Okay? So I plugged it into this one, got z, and now that I have x and z, I can find y. So I have 4 plus y minus 1 equals 3. Here's my z, and my x is over there. 4 minus 1 is 3. 3 plus y equals 3. Minus 3. Y equals 0. Whew, that was a lot of work. So what's your intersection point?
4, 0.
This is your final answer. What is it?
4, 0, -1.
4, 0, -1.